Good morning, everybody. So, we're going to talk about frequency tables and distributions. We're going to get to what is meant by relative frequency. We'll talk about pie charts, histograms, polygons, relative frequency polygons, and so forth, and then stem and leaf plots. Forgive me. The two types of graphs that tend to be most prevalent in trying to just report things in like newspapers and so forth, and I'm gonna call them histograms, and they really sometimes are bar charts, and then pie charts. You don't see a lot of the other stuff being used in everyday life, but if you are doing statistical breakdowns, you do see the other presentations of data quite frequently. So I'm going to talk about some of them and see how they get built. The first thing that I'm going to do is I'm going to generate a frequency table or a frequency distribution. And I'm going to do this because I'm going to do it this way, this specific way, because your ALEKS homework will have a problem similar to this. And so when we are going to make our bins, and if you watched another video, I showed a different way, or I showed a way to make the categories or the classes for where the numbers landed. But in a situation like this, where you have just ones and threes and fours and a five and some sixes, you can just make it so that your classes, and then let me draw in a table here. Okay, so there's our class, and then next to that we're going to have our frequency, so I'm just going to put an F there for frequency. And what you can do when you just have those values presented like that, rather than large ranges between, you can just say 1, and you can say 2, and you can say 3, and then 4, 5. Let me scroll on down here. 6, 7, 8, 9, and finally 10. And on the in the ALEKS homework, they're just going to have these like boxes around here, and you're just going to put in the 1. So what you're going to do in the frequency is just the count. So we have 1, 2, 3, 4, 5, 6 ones. We have 0 twos. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 threes. Okay, so when we're making our histogram or whatever, this one, the 3 should be the high point. The 4s, we have 3. We have 1, 5. We've got 1, 2, 3, 4, 5, 6s. We have 3 8s, but we don't have any 7s. We have a 9, and then we have 5 10s. Forgive me. And so when we sketch out the histogram, we're going to make our axes. And I forgot one thing here. Forgive me. So what's going to happen now is we get these things called class boundaries, and I just abbreviated CB for class boundaries. And what the idea is, or what the difference is between a histogram and a bar chart, is that the bars touch, they share an edge. And there's actually theoretical reasons behind that to try and get, probability and so forth. But for our purposes, histograms, the bars touch. A bar graph, the bars are separate. And our class boundaries are going to go from 0.5, and then they're going to go to 1.5. For the 2, it's 1.5. There should be a point there, to 2.5. Now this is particularly difficult to do on the touchpad, so I'm going to trust that you see what I'm doing, and just travel that on down here, and then just travel that on down here. And so our frequency, there's 10, 11, 12, because that's the highest that we go. And then we put our demarcations on the x-axis. And I'll just make a couple of comments here. You really should always have a title, and you really should always have labels for both axes. Okay, so this one should be your frequency, and whatever the frequency that you're talking about, and then here you can have whatever your units are for classes. If you're talking about numbers of dogs, and or not numbers of dogs, forgive me. I don't know, I'm just creating numbers, so I don't have anything to put here necessarily, so I'll just call it the classes. And whatever your classes happen to be, so, you know, class 1, class 2, class 3, so those could be grades, that kind of thing. You know, first grade, second grade, third grade, so forth. And then you have to give it some kind of title, so we could say school, and just pulling words out of the air here. So I'm try and change my color. It might help see this a bit differently. Nope, I don't want that. What do we got? All right, we're going to go to red. See if that'll pick up. So what's going to happen now is to get the bars to touch, and you can have empty bars. That's or empty spaces. So the 6 goes from from 0.5 to 1.5, and then we're going to have a 12 from the 2.5 to the 3.5. So we're going to go all the way up to the 12, and then we're going to bring it on down like so. And then we're going to have 3 from the 3.5 to the 4.5. And I kind of missed with my 3. I'm a little bit low, so yeah, I screwed that up. And hopefully you get the idea there, because it's fairly tedious to do this and probably very boring to watch. So my apologies for that. All right, so we're going to generate a frequency table from a data set, and we're going to do it like we did on the videos that I have of old. So let me go home, let me get me to type again. I'm going to hop down here. Good deal. And I'm not going to go crazy with a bunch of numbers, but I'm going to put about 20 numbers down. So we're going to do 5, 15, and I'm going to do them lowest to highest to help us kind of see things going on. So 19, 20, 25, 25, 30, 35, 35, 37, 38. Oops, forgot my comma. We're going to have noise in the house soon, so my apologies. I'm trying to do this before everybody wakes up. But so 39, 40. Let's jump to 55, and we'll go 60, and we'll go 61. We'll go 62. We'll go 65. We'll go 70. And let me see how many numbers I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19. And we'll do 75. All right, so what I'm about to do is a way to generate a histogram. Now let me point out that, not a histogram, a frequency table. You generally like your class widths to be the same size. The number of classes that we typically work with is somewhere between 5 and 20. If we have a large data set, you go bigger than 20. We don't really like to go a lot smaller than 5. Sometimes you'll see like 3 or 2, and those are really considered bar charts. But when we're dealing with histograms, we like to have the 5 or higher. And the reason is actually tied into what's called the empirical rule. But uh, we'll deal with that at another time. So again, this is a way to do it. It is not the way to do it. Oh, I forgot a couple of things. So thing number one is that you would like to have your first. Hold on. Lost my train of thought. I said you want your class widths to match. I did say that. You'd want all your data points to be used. You want your first class and last class not to be empty. You can have empties in between, but not in your first class or your last class. And then there's one more thing I'm thinking about, and I can't remember what it is. Oh, I remember what it is. So there are times when you will generate a class width, and you'll end up not capturing the last data point. My comment will be, don't increase your number of classes. You've got to reset what you did. You go back and you increase your data, your class width. You increase your class width by 1. So you round up another piece, and you'll see what's going on in just a second. So a way to do this is to begin by taking the range. So we go 75 minus 5. So we take the high number minus the low number. That's called the range. And we're going to get a value of 70. Now, we have a small data set, so we're going to go with 5 classes. So our next step is to do 70 divided by 5. Now, 70 divided by 5 is going to give us 14. Okay. Now, what's going to happen is I'm going to generate a frequency table using class widths of 14, and what's going to happen is this last data point, 75, might not have a class. And remember, we've chosen 5 classes, so I'm going to draw our little table here. I'm going to go and do, let's do a darker color so it's easier for me to see. So that's not very easy to see. Let's change that. My apologies. I'm going to go here, see if this works better. Yeah, that does work better. All right, so here's our class, and here's going to be our frequency. So what we'll do is we're going to start at the lowest number. This ensures that our first class contains a value. Now, we're going to take 14, and we're going to add it on to 5. And so we're going to have 19. So what we're generating right now are the lower class boundaries. Okay? We're going to take 14 and add it to 19. And we're going to have 33. Okay? We're going to take 14, add it to 33, and we're going to have, we're going to have 47. We're going to take 14, add it to 47, and we're going to end up with 61. I think that's right. Let me double check and make sure I didn't screw anything up. I'm notorious for messing that up. Okay. Yay, I didn't mess it up. So we're not at the spot where we're generating class boundaries. We're not making the bars touch yet, but we are completing our classes. So what we're going to do is we're going to take this 19 that's here, and we're going to subtract 1, and we're going to go 5 to 18. Now, we're going to take 1 away from 33, and it's 19 to 32. And then 1 away from 47, and so it's going to be 33 to 46. And you'll notice the distance from 18 to 32 is 14. The distance from 32 to 46 is 14. So this 14 presents itself multiple times. So this will be down to 60. And part of the reason that I brought up the 14 is I'm adding 14 to get on the upper class boundary. So this is going to put me at 74. Now, you'll notice that I don't have a spot for 75. Okay. Now, before I do what I'm about to do, I'm going to make a couple of comments. If you actually count the number of spots from 5 to 18, these are the number of options. Your class width, the 14, is the number of possible options that exist. So it's 5 to 18. If you count 5 to 18, 5 being 1, 6 being 2, and you do that all the way through, you're going to have 14 options. That's what the class width indicates. It's the number of options that are available. Now, this 75 doesn't have a spot to land. So what we do is we go back and we rebuild our frequency table, and we take this 14 and we increase the size by 1. And so we go instead by 15s. We start off the same way. So we're going to have 5, and then we're going to have 20, and then we're going to have 35, and then we're going to have 50, and then we're going to have 65. We're going to subtract 1 off again, so it's going to be 5 to 19. We're going to have 20 to 34. We're going to have 35 to 49. We're going to have 50 to 64. And again, we're adding 15 on each time. And so this last one's going to be 79. So each data point now has a class in which to land. So let's see how many we have. We're going to have 3 for the frequency from 5 to 19. From 20 to 34, we're going to have 4. It helps to have the data lowest to highest. Then 35 to 49, we're going to have 1, 2, 3, 4, 5, 6. So we're going to have 6. 50 to 64, we are at 4. And then we have 3 at the end. Now, making sure I counted right. Good. I'm going to pop to the next screen. So, to make our class boundaries, come on, draw. It's not letting me draw. Nope, don't do that. Just a sec. Maybe it'll let me do that. There we go. No, it'll let me go. I don't know why it did that, but it did. So our class boundaries, again, I'll abbreviate it with CB, are going to make the classes touch, or the boundaries touch. So this 19 and this 20 need to meet. So what's going to happen is, in order for them to meet, they've got to meet at the halfway mark. So whatever that halfway mark between them is, we use that value. So we have 19.5 now. And the 34 and the 35 will meet at 34.5. So we're going to have 34.5 and then 34.5. Now there are a couple of things that I've left off. I'm not done yet doing this, and it's fairly challenging, so just forgive me for the sloppiness of it. So then we have the 49.5, and then we have this 49.5. Then we have this 64.5. You can hear the noise in my neighborhood. So my apologies. Here's my 64.5. Now, I left the first and the last one open because we just kind of need to discuss some ideas here, and they're not that idea laden, I suppose. It's more procedural. But if you'll notice, the 20 moved left to 19.5. 35 moved left to 34.5. The 50 moved left to 49.5, and so on. So what's going to happen with the 5 is it's going to move left, and it's going to become 4.5. And then the 79 is going to move right because all of these moved right. So now this is at 79.5. So when we're making our histogram, what's going to happen is we're going to use the class boundaries, and I'll just again call this classes, and then up here is going to be our frequency, and then we have to give it some title, but I'm less than concerned about that at the moment. So you do have to do that. So what's going to happen is you're going to start, and you really should do a number line, but again, fairly challenging by just using a touchpad. So I'm going to ask for your forgiveness here and just go 4.5 to 19.5, and then 19.5 to 34.5, and then to 49.5, and then to 64.5, and then lastly to 79.5. And then you have your frequencies. Now, this distribution, forgive me for my poor drawing there. Then we go up to 4, then we go up to 6, and then we come back down to 4, and we come back down to 3. This distribution is the beginning of a symmetric distribution. It looks reasonably normal. And what I mean by that is that a normal curve is that bell-shaped curve, and we're starting to see data that presents itself sort of in that fashion. So that's what they mean by a distribution. What does the shape of the, if you just overarching curve over that, what does that look like? Okay, so see if I can't erase that. Good. All right. Now, I don't really have space to fit what I want to do here, but I'm going to try and see if I can cut this and paste it. So good. I'm going to grab this. I'm going to drop it here. Oop, I got to move this down. Good deal. All right. Stuff got kind of messed up, but it just happens. I apologize. I need that there. Good. Good. All right. So it's not perfect. Forgive me. Some stuff's muddled here, so I'll try and scoot that aside to there. Won't let me. It's giving me fights. Let me erase that. Good deal. All right, back to here. Get the black going. Gray, black. Good. And there's our axis again. All right, so I'm going to try and grab this one more time and see if I can't bring it down so we can work on it. Try one more time. Good. Okay. It's not perfect, but hopefully it'll make sense what I'm about to do. So the next thing we're going to do is we're going to try and generate what's called the relative frequency. And to do that, what we need to do is do counts and out of a total. So I'll abbreviate this RF. So it's going to be the relative frequency. Now the relative frequency leads us to a lot of things. It's how we build, or what we use to build our pie chart. It's what's going to help us with a relative frequency polygon. There's a lot of parts to it that are available. So to get the relative frequency, you know we have 20 in total. So this relative frequency is going to be 3 divided by 20. And that's the first one. And what I'm going to do, because I'm seeing I've made it very difficult for me to write in there, So 3 divided by 20 is going to give me 0.15. So the relative frequency is going to be 0.15 here. And then the next one is going to be 4 out of 20, which will be 0.25. I'm sorry, 0.20, forgive me. The 6 out of 20 is going to be, I have a hunch 0.3, but I just want to make sure. Yeah, it's 0.3. And then it'll be 0.2, and then it'll be 0.15. All right, so those are our relative frequencies. If we're going to make a relative frequency histogram, the only thing that changes is our axis changes. And so the shape stays the same. The boundaries for the x-axis stays the same. What does change is the following. Your axis your axis, instead of being counts, your axis becomes percent. So here's 0.5, here's 0.10, here's 0.5, sorry, 0.15, here's 0.20, here's 0.25, and then here's finally 0.30. So here's our 0.3, here would be our 0.2, here would be our 0.15. And instead of saying frequency, you put relative frequency. And again, you give it a title, and you make sure you talk about the class boundaries, and you make sure you say relative frequency, because these are not frequencies anymore. They are percentages. They are relative frequencies. So that is a relative frequency histogram. So you can do a frequency histogram or a relative frequency histogram, and the axis, the vertical axis, has to indicate that. All right. Now, what's the next one? Did that. Now pie charts. Okay, so a pie chart. And I will never ask you to make a pie chart, but I will ask you some questions on the test. So basically, what ends up happening is that the 0.15, the 0.20 will dictate the size of the angle on the pie chart. And so what happens is you have to start with and create a thing called a central angle. And now a central angle is built off the center of the circle. That's all. It just means it's from the center. And so you take the relative frequency, the 0.15, and to get its angle measurement, you multiply that by 360. So that is supposed to be a times symbol right there. So 0.15 times 360 is going to give me an angle of 54 degrees. So if we had so 360, and we're taking, so 54 degrees. If we had a protractor and we put the protractor down and we measured out 54 degrees, it'd be something like that. And then what ends up happening is I'm sure this is going to be shocking to you, you give the pie chart a title and you label each wedge and you define each wedge. And you often, not always, but often give indication to the relative frequency, either by doing the angle or by stating the relative frequency in there. Okay, so I've got 54 degrees for the first one, and I'm going to take 0.20 times 360. And you're going to have 72 degrees coming out of that one. And so what you do is you pick up where you left off. You'd set your protractor here and you'd go 72 degrees. You'd be something in that nature. And then again, you'd label it and so forth. The thing that I tend to talk about is, how do you end up getting the measurement of the size of the central angle? Again, the central angle being here or the central angle being here. And you're going to take the relative frequency and you're going to multiply it by 360. That's how you get the size of the central angle. Um, Computers deal with this all the time, so part of this is a bit archaic. It's just so you know a way or how it gets built. Let me scroll down here now. Come on, where's my cursor? It's not letting me work. Just a second. So we did pie charts, we did histograms. I do need to talk about your polygons. So I'm going to use this as a basis for a relative frequency polygon. You can do a frequency polygon. It works out, the idea works out the same. You're just doing frequencies rather than relative frequencies. So I'm going to erase these pieces parts here. That's my garage door opener. All right, so to make a polygon, you have to have a closed or an enclosed a graph. And so what happens is you have to have a starting spot and an ending spot. But the problem becomes that you have these heights, and so we're going to work off the midpoints of each one of these regions, and we've got to respect the relative frequencies or the frequencies that we've gotten. So in the middle here will be a 0.15. In the middle here will be a 0.20. In the middle here will be our 0.30. Back to our 0.20. Back to our 0.15. So what we do is we take our class width, and again, we got our midpoint, so I ignored how to get the midpoint. Let me talk about that real quick. You're going to take the endpoints, the 19.5, and you're going to add to that the 4.5, and you're going to get 24 out of that. So you've added those two values, and then you divide that by 2. So you're going to take the 24 and you're going to divide it by 2, and this value here is going to be 12. So that mark is 12. Okay. Now, once you have the first midpoint, all you've got to recognize is that you go up by 15, and so this is going to be, whoops, that's weird. Didn't mean to do that. My apologies. This one will be 27, because you, again, add 19.5 plus 34.5, and you divide it by 2, and you're going to get that midpoint to be 27. And it goes up by 15, and if we go up by 15, we'll be at 42. So here's our 42. And so I'm just getting the midpoints. Now, the nice thing is that these distances are consistent. And that means that what I can do, or what I'm going to do, is I'm going to go back 15 units, and I'm going to go to 12 minus 15, getting me a -3. So my value over here is going to be at -3. So the polygon is going to start, remember, it's got to be an enclosed, in order for it to be a polygon, it's got to be enclosed. This is different than a line graph, but it is a version of a line graph. So we go up, starting at -3, going to 12, and then from 12 to, when we're at the x-axis at 12, we're up at our 1.5. When we're at the x-axis 27, we're up at 0.2. When we're at the x-axis of 42, we are up at 0.3, and then we work our way back down. And forgive me for that little hiccup there. I don't know why my touchpad's doing something funny. And then let's see if I can get it to go straight that time. There we go. And again, we're going to go 15 units that way. So this mark is at the 57. This next mark here is at the 72. And then this last mark is going to be at 87. And we set our dot, and we have completed a relative frequency polygon. And again, the key here is to get that tail out so that we have uniform width. Each of these line segments represent an equal distance. And so it's just a visual to give you an idea what it looks like. And we sketched that normal curve in earlier. I think it disappeared, but again, we're starting to build that sort of bell-shaped symmetric curve. I haven't talked about distributions at this point in time, but I want you to keep in mind that shape. All right, so we did the polygons. Last piece is the stem and leaf plot. Okay, see if I can get this to give me another sheet of paper here real quick. Where's my cursor? Everything's moving down. I can erase when I get it to the next sheet. There we go. All right, so erase. We're going to erase that. Erase, 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 erase. Doing a lot of erasing here. That's a screenshot that's above, so I don't know that I can erase that. I might be able to delete it. Let me see what I can do. My apologies for taking the time to do this. So let's go back to our, there we go, got rid of it. Let's go back and let's generate our data set, or recapture our data set. Bring that forward. And we'll use that data set again. And we will erase the line that's here and the line that's there. Okay. And again, it's helpful to have the data lowest to highest, but to generate a stem and leaf plot, and you can see different versions of this, but basically what ends up happening is you have a stem, which is generally the lead number, and then you have what's referred to as a leaf. And you need a key of some kind. So like you would go 1, 5, and you'd put this bar between it, and you'd say, oh, that reads as 15. So the 1 is the stem, and the 5 would be the leaf. And it's kind of a way to keep track of your data and see what the distribution could look like, assuming that you tilt your head on the side. But so the stems that we're dealing with are 0, and we have 1s. And you don't skip a stem even if the stem is missing. But leaves, hold on, let's see what I have. We have the stems. Even if a stem's missing, it's okay to put it in. You're trying to keep track of if there's any gaps for that reason. So our first stem would be 0 because it's just plain 5, and our last stem's going to be 7. I'd said something about leaves. There are times that we will do a double stem and leaf. So if you have a lot of numbers, you might see 0, 0, and then 1, 1, and then 2, 2, and you have the count of 1s, 2s, 3s, and 4s on the bottom stem, and then 5, 6, 7, 8s, and 9s on the top stem. Or I'm sorry, I said bottom. Flip that on the top stem and the bottom stem, and I can give you a demo what I mean by that in a minute. So we just have a 5 here. Now we have a 15 and we have a 19. So to represent 19, it's the 1 and then the 9. To represent the 20, we're going to put a 0, and we have two 25s, so we're going to write 5, and then we're going to write 5. We have a 30, a 35, a 35, a 37, a 38, and a 39. So we have a 30, we have a 35, we have a 35, we have a 37, we have a 38, we have a 39, and then a 40, and then a 55, a 60, a 61, a 62, a 65, a 70, and a 75. Now, if we had a very large data set, so let me take this data set, and let me see if I can get back to what I was dealing with before. Sometimes you'll see a double stem. And what I mean by that is just pretend that we had this set of data twice. And it's going to take me a second here. Let me see if I can just quickly capture this and delete it. Nope. See if I can't just... Nope, won't let me. Okay. So what I am going to do, however, is I'm going to generate this data set twice. So we have that data set now twice. And we've got a bunch of numbers. So what you might see is something of this nature. If you have a large data set and there's a lot of values, you very likely could see the stems look like this. So they would do a double stem and leaf. And then 1, 1, and then 2, 2, and then 3, 3. And what they do in this case is, if it's below 5, you would put it at the top stem, and if it's 5 to 9, then you put it at the high step. Wait. 6, 7, 8, 9. Yeah. So 5, 5, and then 15, 15. So you'd see 15, 15, 19, 19. And then at 20, you've got 2 20s, because remember I doubled the data set, and then you got a bunch of 5s, so you'd have 4 5s. And so it's just a way to deal with very large data sets and still trying to keep things sort of visually pleasing. Not always a great tool, the stem and leaf plot. I've only seen them used a handful of times, and I've been dealing with statistics for some time now. All right. I hope that helps. I hope it makes sense. And have a good one.